everyone. Welcome to today's webinar, Critical Power for an IoT Connected Environment. I'm Ann Cosgrove, the Editor-in-Chief of Facility Executive Magazine, and this webinar is presented today by Schneider Electric. Before we get started, I'd like to cover a few housekeeping items. Please note the control panel on your screen. This is where you can submit questions for our presenter in that question box. You can send these in at any time, and our speaker will address them during or after the presentation. Also, please note the orange arrow on the left side of your control panel. Clicking on that arrow will either expand or collapse the control panel, so please be sure it is expanded so you can access the question box. Also, if at any time you experience a technical difficulty, you can send a message to us in that question section and we'll address it right away. Now, I'd like to introduce your speaker today, Dan McGinn. Dan is the Director of Secure Power Systems at Schneider Electric, and in his role, he is responsible for business development strategies and execution in the area of uninterruptible power supply and related technologies for the industry and infrastructure spaces. Dan works across multiple business units within Schneider Electric to address the secure power needs of varied market segments. He has more than 20 years of experience as a business and technology professional in the arena of process automation, energy management, and manufacturing IT systems, with extensive experience in the application of UPS technology, including three-phase systems and redundant power generation. Dan has a Bachelor of Science degree in Electrical Engineering from the University of Michigan at Ann Arbor. So with that, I will hand it over to Dan. Welcome, Dan.
Thank you, Ann, and I'd like to thank Facility Executive for the opportunity to discuss this topic with you fine folks today. I'm very excited to talk about this. There's a lot changing and evolving in our facilities world, and we're going to talk primarily about some of the trends that are affecting the way we look at systems within our facilities, which is going to lead us to the ultimate topic of critical power solutions. So thank you, and we shall begin. I'm going to talk first about some of these trends, some of which you may have heard a lot about. There's a lot of buzz, a lot of excitement around particularly the Internet of Things. The Internet of Things is, as you can imagine from the term, this very catch-all phrase that's describing a trend that involves all manner of devices within our facilities, within our homes, within our manufacturing plants, and even in extended environments outside of those spaces. A lot of discussion, a lot of hype, and one of the things we're going to talk about is how the reality may match, or in some cases not match, the hype around the Internet of Things, and then the impacts of this IoT connected world on things like critical power. We're also going to talk about some other trends which are not entirely different trends. In many ways, they're related and overlapping trends. They may represent a slightly different perspective on a lot of the same elements. They may represent a subset of this trend that falls under the Internet of Things space. You may have heard some of these phrases, you may not have. The Internet of FM, or the Internet of Facility Management. Just like in the industrial space, we have the Industrial Internet of Things. Again, it's really just a different perspective, a different set of nomenclature on the same thing, but we're talking about that highly connected world. Another thing we're going to talk about is IT and OT convergence, IT being information technology, OT being operational technology. Depending on the space you're in, that may be referred more to facilities technology or manufacturing engineering technology and so forth. Another buzz phrase you may have heard is Industry 4.0. This actually came out of Europe, but it's a reference to this idea that what we're seeing today in the current transformation of our connected world is actually the fourth phase of the industrial revolution, from a highly mechanized beginning to an electrified second phase to a computer-driven third phase to now a sort of autonomous data-driven phase. And then tied into all of that is another trend called big data for manufacturing, or big data in general. And you can think of it as big data for facilities or big data for buildings. But the idea is, with all this data that's becoming available to us, how do we manage these systems differently, and what is the impact of that data on those systems? And kind of to illustrate the level of buzz and hype, so to speak, I wanted to kind of show you that I myself did a presentation at NFMT where I met Ann earlier this year. Article recently in Facility Executive. Other spaces like ISA and other publications are talking about the industrial aspect of this. So again, a lot of buzz. Schneider Electric is publishing articles. There's lots of speakers at different presentations. So we're going to talk a little bit about this, but I'm pretty confident that we'll give you a little bit different perspective and some things to think about this that don't necessarily come through in some of the 50,000-foot presentations and discussions you've seen around the Internet of Things. That said, though many of you have heard the term, most, if not all of you, some of you even may be sick of hearing it. As I said, there's a lot of hype around it, but we are going to set a baseline for our discussion, at least in the perspectives of what we're talking about when we talk about the Internet of Things. And what differentiates it in at least the perspective of myself in this presentation is we're talking about web-enabled connected devices beyond PCs and servers. So evolving past the idea that the Internet is connecting computers, so to speak. A first step in that evolution is to begin to connect things like, thin client devices like our iPads, HMIs in our facility control and industrial control systems as an example. But what we're really talking about in those cases is devices that are serving purposes that used to be what we did with computers. And then as a next step, we've moved into more connected devices around intelligent systems in the facility management space. That would be like your building management systems, your energy management systems, other industrial control systems. But we're also beginning to talk more and more about cameras and security systems, IP connected devices that aren't necessarily thought of as in the past as an intelligent device, more autonomous, more intelligence. And then we move from those devices to what I really like to think are the true things. Where we're talking about devices that don't have classical operating systems, they're not programmable, and in large part, or at least historically, they weren't. These can be any manner of sensor and intelligent devices in a building management world. It might be, for example, a temperature sensor. In our home, it could be anything from things like, thermostats to security systems. And I do believe, just to give you a mundane example of where it's going, someday your doorbell will be connected to the web, whether by a wireless connection or connected to a security system, all manner of mundane systems. Also systems that aren't, or systems or things, I should say, that aren't necessarily physically connected or stationary. Shopping carts. Believe me, the retailers would love to know how you travel through their store, what things you look at, what things you pick out. Farm animals. You heard it here first. I do believe you will see that yellow tag on the cow's ear that had a number is going to become a transponder, and people are going to begin to manage their farms with things. So I'm just trying to give you the idea of this idea that everything is connected, everything is intelligent, everything's providing data. I would even say it is ourselves. Yes, the matrix has arrived. If you think of, if you have an Apple Watch, if you have a pacemaker, if you have any type of device that's associated with your presence, even your phone, the Internet seems to know where you are, what you're in the market for, what type of food you like if you're looking for dinner. It's a connected world, and it's becoming more and more connected. In our facility management space, there's certainly implications for that. So talk a little bit about the impact of this industrial Internet or facility Internet. How big is it? And the answer is, I think it's very hard to say. We've seen estimates of IoT spend from 1.7 trillion by Cisco or by IDC, and then much bigger estimates from Cisco and others of 14 trillion, 11 trillion. What that really tells you is the size of the numbers and the disparity of the numbers. That means a lot is left to interpretation about what truly constitutes the Internet of Things, okay? But what we will clearly see is continued growth in the number of web-enabled devices, connected devices, and the connections to those devices. Many of those devices have those connections. We'll continue to have more of them, but they aren't necessarily connected or exploited. It may be that you can't buy a thermostat 5-10 years from now that doesn't have some sort of web-connected availability, whether you use it or not. But we'll briefly talk about what does all that spend, what is it made of? Well, it can be the things, the devices, so to speak. The connectivity, that is the network infrastructure, be it wired or wireless, that actually connects all these devices to the World Wide Web. The data infrastructure, if you think you have an exponentially growing number of devices and an exponentially growing amount of data from those devices, that data has to be stored somewhere, go somewhere. So you're talking, cloud and data center capability. There's certainly services to create, manage, and support that infrastructure, and also to companies like ourselves, and if you're not in the end user space, some of our service providers, your value chain services made available by us analyzing that data and providing value add back to you. So the reason this spend idea is important to you is because once we begin to monetize this Internet of Things, that's really when it begins to truly take hold and take off. And it's also a real view into what we're talking about in terms of deployment of these systems as opposed to simply putting web connections on devices. One thing I love to show, I love this graphic. This is from our friends at Gartner, which is an industry analyst if you're not familiar with them and have seen this in various forms. It's a bit of an eye chart. Don't worry, you don't have to read it all. But it's what they refer to as their emerging technology hype cycle. And I think this is just fantastic. What they're talking about is how a lot of trends like the Internet of Things, and if you can't read it, or if you can, at the very top of what they call their peak of inflated expectations is the Internet of Things. And their hype cycle would have us believe that we're headed for this trough of disillusionment, that we're going to see this hype turn into something much less than current expectations and current activity would have us believe. And I believe there's some truth to that. But the important thing to note is that we've been putting web-enabled services into devices, more and more devices, for a very long time. They aren't always connected. They aren't always leveraged, but we've been putting them out there for a very long time. So from a deployment perspective, we may be much further along than a typical trend might see. And so I'm inclined to think that the jump to where we're truly realizing value and improvements in productivity and operations from the Internet of Things is a shorter jump than the typical hype cycle may realize. Nevertheless, there's some truth to it, and I think it's a good perspective to carry with us as we think about the evolution of these trends. Another trend I talked about, which is related, is this idea that operational technology and information technology are converging. To some degree they are converging, and another way they have to converge. If you think about the network infrastructure that is going further and further into your enterprise to connect the most mundane devices, the IT technology that is typically used to manage, monitor, secure networks to endpoint devices, the server systems and the network systems that are involved, they require a lot more thought management, critical power protection to kind of lead into the ultimate topic of what we're talking about. In order for these systems to remain available and serving our process needs to the level that they should be if we're truly going to rely on these systems. So what we're seeing is the need for IT-OT convergence, and we're seeing IT-OT convergence. The other thing which we need to see is if this is going to work. Historically, your OT departments or the areas of your company that were OT may have been highly segregated from your IT. Generally, they wanted to stay out of each other's shorts. They didn't want to be responsible for each other's systems, and they were managed separately. More and more, with IT-OT convergence in terms of technology, we see the need for convergence of IT and OT in terms of departmental collaboration, and we'll talk more about that. Another trend that we mentioned is Industry 4.0, and I like to talk about Industry 4.0 because, one, it shows how we see this not so much as a revolution, but an evolution, and that a lot of this stuff has been going on for a very long time. Companies like Schneider Electric and others have been putting web-enabled devices into your facilities since the 90s, and depending on how you view it, even since the 80s. But I really would like to talk about the perspective of the Internet of Things and Industry 4.0, not so much from the Internet perspective, but from the thing perspective. And I think this provides a little bit different context for how you view the Internet of Things and some of the implications that we'll talk about in a bit. But if you think about a sensor, take a temperature sensor in your building. Years ago, that sensor would have been connected to a controller somewhere by a wire, either a dry contact signal or potentially an analog signal indicating temperature, and it was a point-to-point connection. Today, that same sensor might be connected via network to the controller. It might be a dedicated network, it might be an Ethernet network, but it's generally a network layer that is isolated or segregated from the larger World Wide Web, therefore not, as we like to say, the Internet of Things. Tomorrow, that sensor may be monitored by multiple applications from multiple points within a company, multiple departments that may have interest. You may have a maintenance department that's responsible for those devices across a facility. You may have a department where that sensor exists that's interested in. One may view it in one environment, like a building management environment. One may view it in different environment like a maintenance management system, but it's the same device and ultimately the same connection, control as well. Get technical for a moment, but I wanted to talk a little bit about IoT, Internet of Things, and data abstraction, which relates just and very closely to the sensor discussion that I just had about Industry 4.0. And again, if you think about that sensor, historically that sensor, which we call here an intelligent device, had a connection up to a machine or appliance that might have a controller in it. That machine or appliance has a connection up to a monitoring system that might be SCADA-based, software-based, probably on a server, but it's connected that simple. And then from there, if the data is to be made available to the larger enterprise and ultimately to the World Wide Web, it's going to come through that path. So everything has to be mapped from one level to the other. And if you think about a modern web-enabled IoT-connected device, it may have hundreds of parameters on it. It may have web pages on it. You're not going to map all of that in your programming to the controller, to the upstream monitoring system, to the enterprise. It's too much work. It's too much critical bandwidth that's available for control used. But in an IoT world, you don't have to. So if you think of something, again, let's use a temperature sensor. You could conceivably have somebody in a department like maintenance that's responsible for all of the, say, mechanical equipment in your facility. And they're going to have a high-level knowledge of the mechanical systems and maybe some knowledge of that sensor. But conceivably, you could have somebody that's responsible for that sensor and every iteration of that sensor across an entire facility and knows that sensor in depth, is going to have a great deal of interest in the data on that sensor, much more than you would map to the machine or appliance. And this may extend even beyond the borders of your building and of your company. It might be the sensor supplier. It might be your mechanical equipment supplier that's interested in taking that data, aggregating it, analyzing it, and providing value back to you, possibly letting you know that you have a pending motor failure, as an example. And believe me, there's a strategy for manufacturers like ourselves that make devices, as well as our competitors, to what we would term in Schneider Electric as acquire and connect, which means when you have our devices in your plant, we want to be able to provide value to yourselves and the value chain that exists between ourselves and your end facility, to take that data, connect that data, monitor it, be able to provide value back to you, whether it's maintenance indications, diagnostics, whatever the case may be. So again, if we think back to that idea of IoT spend, this is where all of that comes in, and this is also where the value potentially comes from for your enterprise. And what I want you to begin to think about when we're going to get through this critical power aspect of it is, as we evolve, and if you as facility operators, building management operators, C-level executives, expect to see your operations remain competitive in an increasingly competitive world, you basically have two areas you can go to. You can either just flat out try to cut costs, or you can look for ways to make your operation more productive, more efficient, and that requires data and analytics and looking at things in a continuous improvement type way. So what is the value? Again, IoT, as I see it, is big data for your enterprise. How are you going to realize that value? Well, you're going to realize it in terms of competitiveness, improve productivity and operations. You're going to have an opportunity to leverage that data in the context of continuous improvement. And I put opportunity and can be in quotes for a reason, as well as that the connections allow you to collaborate across disciplines. There's nothing that says you have to. Okay, if you think of MES systems or maintenance management systems or building management systems, there's nothing today that says you have to take the data available from those systems and use it for a process of continuous improvement. And there will be companies that put into place grand IoT strategies, have a great deal of connectivity, collect a great deal of data, but if they don't do anything with it, if they don't have a culture that uses tools over the top of things like manufacturing execution systems and management systems, tools like Six Sigma and other tools to actually look at how you can improve your operation, then the value is questionable. So the value is not just in the IoT, but it's what we do with the IoT. Competitiveness, continuous improvement, system availability.
And excuse me, Dan. This is Ann, if I can just jump in for a moment. I did want to ask you, we have a question coming in about that the content on that slide related to that. If you can just kind of delve a bit more into what about the Internet of Things changes the landscape with respect to analytics and the continuous improvement that you were just discussing.
Thank you, Ann. Yeah, what you have now, if you make this transformation from a hierarchical network view of the world where you're feeding data up, from the devices up through the control systems to the data collection devices, you're filtering the available data to a smaller and smaller pool as you get to the top of the system. And from a control system perspective, which is the discipline that's usually putting these systems in, you're filtering that down to the data you need for control, not necessarily the data you need for in-depth, context-specific analytics. And if you can go get that data directly from the devices, then it allows for a lot more specialization. And again, it doesn't have to change anything for you. You don't have. In fact, if it's not going to change anything from a culture and collaboration perspective, you could make the argument that it's not worth changing the technology in the first place. If you're going to adopt the technology, then the analytics available to you grows immensely, and the value comes in terms of what you do with those systems. I'll give you a parallel example. MES, if you're in the manufacturing space, may be familiar, but Schneider Electric is also very involved in the energy management space. You may know we're the world's largest manufacturer of energy meters and special purpose energy monitors. And if you think of, when people put those systems in place, you can put the energy management software and analytics in place 6 ways to Sunday, but if you're not actually taking the data and doing anything with it, it doesn't have any value to you. So the point being is the data can have value. You can leverage that value internally based on the personnel that you have available, but you can also make that data available to value chain players like component manufacturers like Schneider Electric, integration providers like you may use in your facilities to provide that additional value. And all those things that we mentioned, competitiveness, continuous improvement, better system availability, that's where that's going to come from. So thank you. So from a baseline of what is this? What is it all about? So we're talking about the trends. Now we're going to talk about the implications, which is where we get to the subjects that we want to introduce you to from the perspective of protecting the enterprise. We talked about what the value is, where the trends exist. What are the implications within your enterprise? And I'll foreshadow a little bit into the discussion in the sense that, like I said, there's a lot of excitement, a lot of buzz, a lot of high-level presentations that exist at trade shows and elsewhere that talk about the value of the IoT, that you have to get on board, and if you want to be competitive, if you want to improve, you have to do this, and everybody's all about getting onto the bandwagon, so to speak. But what are the implications at the floor level? And where the implications really come into place is when it comes to protecting that infrastructure that is part of the IoT. We're going to talk about two things. One is managed compute and network infrastructure, okay, and high availability power solutions supporting that infrastructure. So let's start with, again, I give a little bit of a baseline, is let's talk about network and compute infrastructure. So if you think of your facility, okay, another term you may have heard, it may be viewed as a trend, is what people would call the edge, or edge compute, edge networking. And where that comes from, again, is a matter of perspective, and perspectives vary. I can tell you from where I come within Schneider Electric, there's a lot of people that are very data center focused. And if you think about the edge as getting further and further away from that core data center, is to corporate data center folks, edge might mean what's left on premises at the facility, the on-premises data center or IT rooms, or that enterprise level within your facility. Of course, the perspective is different if your facility happens to be a data center. So if there's anybody on the phone that is a data center facility manager, that's what I'm describing as the perspective they would see of facilities that the data center supports. Whereas if you're in a facility that is not the data center, to the data center person, you're actually on the edge when you're standing in the data center in the facility. But to most of us that work in industrial and commercial facilities, when we think of the edge, we're thinking of pushing things down even further. And that's into the control rooms, into remote servers and in computer closets and network cabinets and things like that. And we're also even talking about some, systems that exist down on the plant floor, down on the, the facility mechanical space, clients, control panels, and so forth. And if you consider the infrastructure that has existed there, it's kind of been segregated in the past. Down at the device level, you've had a device network. You've had a control network at the control layer that connected different intelligent controller devices level, and then ultimately somewhere there was a bridge that included a firewall to an enterprise network. And that device level network, and to some degree the control level network, might be entirely isolated. Some of the compute assets, and I like to put an example down there on the left, were managed within the departments, and they were not managed like IT assets. Okay, these systems were generally isolated from the enterprise level. They were managed outside of the IT world, and even the IT people would refer to them in many respects as IT sprawl, systems outside their control. And if you think about this more and more connected world that the IoT brings and these other trends, where the network has become flat, there's ultimately a single contiguous network, albeit with, hopefully with, segregation, virtual segregation and security put in place. But the single network, it becomes important to manage those assets differently. And when we begin to talk about managed infrastructure, the idea is to begin to look at how we manage things in the IT or data center space and begin to apply similar standards and constructs in that edge compute and edge networking space, which includes hardware standards, software standards, and yes, critical power protection in the form of UPS systems. So what are we talking about when we talk about these systems? Again, what we're seeing in the industry for people that are, not just talking about these trends at the C-level space, but actually looking at implementation, engaging with the disciplines within the facilities and the departments that are going to be supporting these systems, looking at the risks associated, is this movement towards converged infrastructure for industrial commercial applications. The idea is, it's applications on the edge, managed by the departments, but supported with standards from IT. A story I like to tell is I was in a meeting with people well above my pay grade at our company, and the discussion came up about edge compute. Is it an application or is it an environment? And half the room says it's an application, half the room says it's an environment. But you kind of stop and you realize that everybody that describes it as an application has an IT background. Everybody that describes it as an environment has some other background. And in the case of the edge, what we're really talking about is applications managed by the departments: manufacturing engineering, production engineering, controls engineering, facility engineering, maintenance. Applications managed by those departments, but different than in the past in the sense that they're managed on an environment that has adopted IT standards. And when I say IT standards, I don't simply mean supported by IT, connected to IT, but incorporating standards around hardware, also around software, operating system, virtualization, remote management, and the very important one, the implication we're going to talk a bit about, is cybersecurity. And in the facility management space, a lot of these systems are run off of enterprise, on-premises data centers or IT rooms, but a lot of them are run remotely, or certainly the clients are, or where there's potentially data concentration, and these systems haven't always been managed. So we're talking about BMS, or building management. Security systems is a big one. And you think about all the cameras we're putting out there, and a lot of them are IP cameras. Power monitoring equipment, as I said, Schneider Electric is in the power monitoring space, and I love to ask my peeps from the power monitoring side is, where do you get the power from your, these fancy monitors that you're putting on our customers? And you'd be shocked at how many times they say, well, from the utility power. So let me get this straight. You've got people investing a boatload of money in equipment that's designed to protect power anomalies, and the minute you have a power problem, you lose power to those meters. Again, great example of why you should be looking at some type of critical power protection to those systems. Building networks and applications on the edge, and what you'll begin to see in a moment is we're going to talk about the difference between the intelligence in these systems and the actual muscle power to these systems, and why there's an opportunity in addition to the challenge. The challenge is, of course, being able to keep these systems well managed, operating, and available. The opportunity is to potentially do this at a much lower power level than it would be to, say, power the entire process. So from network and compute infrastructure systems, let's talk about the adoption drivers. We talked about the convergence of IT with OT, or an industrial space manufacturing IT or facility IT. Edge compute, and again, trying to get control of those islands of compute infrastructure that exist within a facility. And with standards, you can even deploy those systems more often out in the field. You know, it's sort of the idea of a data center having all the compute assets collected right next to each other in a single room gets to a point with this, you know, with the remote management and software solutions that we have. The only advantage, I shouldn't say the only advantage, but the most significant advantage to having them all together is really just cooling those systems. So as long as you solve that, then the ability to distribute them throughout the facility becomes a lower hurdle. But what's it all about? Again, if we think of that infrastructure to the things, in an IoT world, we have all these intelligent devices that are providing data and analytics. Quite often the data and analytics is most important when something goes wrong. It's maintaining the enterprise continuity through those events where things go wrong, and also reining in that IT sprawl, that those systems that have existed in an unmanaged way out in the field, making sure that we begin to manage those in a way that reduces our risk to the enterprise. So I mentioned it, but let's talk about the challenges of this IoT-enabled enterprise. You know, think about the things that now we've gone from a space where we had a sort of a single path hierarchical network connection, or connection from devices all the way up through the system, to a very flat open network. What do we need to think about? Well, we need to think about uncontrolled access, cyber threats, network management. How do we deploy applications? And that's not just the original installs, but how do we deploy updates and patches and things like that? You know, how do we not allow, or allow in a controlled way, remote control? You know, I can tell you some exercises I had in my factory automation past where, you know, some very large companies had very strict regulations about doing any type of control of systems remotely because of safety. But what they learned over time is having, you know, complete, you know, absolute rules that said it's forbidden to do any of these things just meant people creating shortcuts which were more dangerous than doing it in a controlled manner. So if you have standards in place, it's actually in some ways safer than allowing no remote access and control altogether. And then change management becomes a part of that. So if you think about the things that go along with that, it's planning around management and mitigation of these systems. How do you deal with those challenges? Having a security plan and having system design and standards in place that address those issues. And again, back to this idea of IT and OT collaboration, this is where that root need comes from. I mentioned cybersecurity. I'm going to mention it again because it's an important one. As I said, at the C level, when you go to trade events and you listen to a lot of people talk about the Internet of Things and these other trends, they're going to talk about all the great and wonderful things you can do with it. And they're right on. But when you get down to the floor level of the people that are managing these devices and you tell them that these systems are going to be connected, that people are going to be viewing them from the World Wide Web perspective, that it's going to be an open system, fully available, you know, at any level, it scares them a great deal. They're excited, yes, but they're also terrified. And if you look at what the industry defines as the attack vectors for control systems, and again, this can be plant control systems, it can be your building management systems, but they're going to identify two areas in particular: network architecture loopholes and unsecured and outdated hardware. Okay, so again, it's these unmanaged systems that are outside of the scope of the IT departments that would normally deal with these types of issues and protect for these attack vectors. So I'm going to give you some questions to carry in your mind around whether or not you should consider the adoption of standard edge compute infrastructure for applications within your process. Again, that's your plant processes, your facility processes. And again, we're talking about, when I say standard edge compute infrastructure, I mean having standards. Maybe not a single standard. You know, in some cases with some clients, we've seen people have small, medium, and large, for example. They might have a regular throughput and an output throughput. They may have a couple variants of just pure network closet type architecture. But the idea is having standards around software, hardware, and deployment and management. And the questions I put out there is, do you have instances of these unmanaged compute environments? I think more companies than might realize actually do, where they have people that have systems that are connected to critical systems within their facilities, that are in offices, in maintenance rooms and such, that they're not even remotely resemblant of the standards that are deployed at the IT level. Can you benefit from those standards? I think we talked about why you potentially can. And also, can partners play a larger role? And by partners, I mean potentially component and equipment vendors like ourselves, but also your systems integrators, if you have outsourced maintenance, if you have partners in terms of design engineering firms and contractors. What role can they play defining that value chain, so to speak, so that you can actually deploy these standards? Because in many cases, those remote uncontrolled computer systems weren't necessarily procured in-house. They might have come in as part of a system, if you understand what I'm saying. From there, I'm going to talk about UPS systems, okay? And again, I want you to think about that connected environment. Now we have all these devices, all this data, all these brains connected over this network that enables the Internet of Things and analytics and so forth. And if you think of this world, it's a 24/7 world in many respects, even if the active operations are not. If you think, for example, about a production plant, the plant might run 2 shifts a day, but the events that could potentially affect the system can happen at any time. And quite often the events, even if they do involve a managed shutdown as opposed to an interruption of power or some other type of event, be it safety sensors or anything like that, you want the connectivity to remain there, to have that analytics, if nothing else, to understand the state of that equipment during the time that the power is down. So it's a connected enterprise, and having that connection available all the time, even if you're not drawing power from the system and producing product, if it's a manufacturing environment, producing a constant temperature, for example, if it's a mechanical systems environment. But the proper application of UPSs can help assure that those systems are there. So we talked about standards and compute infrastructure, but we also need to think about providing power to those systems. And if you want them to be highly available, the power to them needs to be highly available. And what are we trying to prevent? Well, lost data, enhanced systems diagnostics, certainly. If you've been around these systems, one thing you know is quite often the system diagnostics during a power failure or partial power failure are just a cascade of meaningless faults that are actually a result of communications interruptions, power interruptions, and not necessarily pointing you to meaningful information, and in fact clouding your ability to see meaningful information from from historical data. Also helps provide for safe and efficient system shutdown and startup. Systems don't start up. The example we use is if you have a 4-second power blip, chances are you're going to have a much more substantial outage than 4 seconds, just because of what it takes for the systems to come back online. And in a lot of cases, those systems require intervention, not simply the power coming back on. So drivers for the adoption of UPS, and many of these exist outside of the IoT world. The trends speak more to what we would talk about the intelligence of the system, but the drivers that have existed for the larger elements of the process in your facilities have been there for a very long time. It's essentially an insurance policy. Insurance for the facility itself and for the process, but you're trying to avoid financial costs and risks, keep your systems more highly available, and also within critical power solutions, you're also going to have much cleaner power, and the issues associated with power interruptions aren't necessarily the result of a complete power loss. So what are the drivers? Well, we're talking about eliminating things like lost production and idled workforce. Also, in many cases, power losses, be they very short and intermediate or long in duration, can cause damage to some process equipment or facility equipment. And not to mention, again, we're talking the IoT world, the loss of facility and process information, that data. In some cases, that data can prove critical to the IoT connected analytics that we're trying to build. And in some cases, if that data is transactional, it can be detrimental to your business itself. And then, of course, the other thing that comes into place with critical power is there are places where safety actually does come into play, whether it's the safety of people or the surroundings associated with the equipment, damage to the environment, for an example, things in the process that could potentially result as or create a problem as a result of loss of power. Again, that's kind of the classic summary of drivers. How is it different in this IoT connected world? And in the IoT connected world, what I really like to do is think of the systems that we're looking at protecting in terms of traditional mains applications, main power applications, versus what we'll call the brains applications. Okay, and the mains applications, some of them are very typical from industry to industry, from market to market, building type and facility type to building type and facility type. Things like a data center. Okay, if you have a its own data center. Emergency systems. Now this is dictated by code, but the code's a little interesting in that outside of emergency lighting, which it clearly states as an emergency system, it more refers to, the code really tells you how to handle emergency systems. It doesn't so much define what those emergency systems are. But when you get into things what we would call mission critical applications associated with IT, and then we get to critical process equipment. What equipment is critical to your process? And that's really part of a risk analysis that is done between yourselves, your authority having jurisdiction, your process experts and so forth, to determine what systems require you to put a full power back on in order to maintain the highest availability of those systems, versus those that have some system intelligence and the possibility to protect the power to the system intelligence and the network to that system. That's what we will call the brains. And again, I'll use an example that should be very familiar to facility executives if you think of an HVAC system, but let's go to your home. Highly unlikely that you would ever put a UPS on your AC compressor. Okay, if it loses power for a few seconds, it's no big deal, and it's expensive. On the other hand, if you have a web-enabled thermostat, and that's part of a wireless network infrastructure that also supports your security system and potentially some intelligent appliances, it might make sense to back that up with a UPS, because you might want to be able to adjust the temperature down or up to reduce power, for example, when you're traveling on an extended trip and failed to do so before you left, or you have some sort of alarm or something that occurs as a result of the security system. Much lower investment because you're not investing in full power backup, but also much more valuable in terms of information and an IoT type connected environment. So again, we talk about mains versus brains. Mains where the system is critical enough to require full power backup. Brains, which is really what we're suggesting these trends may have us think about, which is a compelling case to protect the IoT infrastructure as a whole, again, on a relatively cost-effective basis compared to higher power full-blown backup. Talk about some of the applications for both UPS and edge infrastructure that are very common across different types of facilities. If you look at different facilities, it could be an automotive plant or an office building, they're still going to have emergency lighting. Good place for UPS systems. Energy management and control systems. I used the example of metering earlier in our own people in terms of if you're going to have metering and expensive circuit monitors, you want those systems to be available when they provide the most value, which is when you have some type of issue going on with the system. And again, that's part of your IoT infrastructure, is all these intelligent connected devices. Building management systems, right at the core of what we're talking about in terms of facility management. Security, again, the explosion of DVR and IP cameras all over the place, as well as control rooms. Good applications on the brain side of the IoT connected environment. I want to talk real quick about a layered approach, as we would call it, for critical power or secure power in an Internet of Things world. Where do you integrate this critical power protection in terms of UPS? And there's a couple ways to do it. And it comes down to a deployment strategy. You can integrate systems with the power distribution architecture, generally in a more centralized fashion, sometimes used in conjunction with a backup generator, which will, time dependent, we'll talk about a little bit. And these are systems that are really tied to the initial design or the redesign of your facility. It's integrated into that structure. There has to be a strategy in place. You can't deploy them ad hoc. The next would be integrated at the edge computer edge networking. That is most often associated with the network to the things, so to speak, to the devices, but also supporting devices that are powered from the network, power over Ethernet type devices as example. And then distributed protection, which is probably what we are most familiar with visually when we think of UPSs, which is UPSs that are provided locally to either machinery or appliances, and sometimes within control panels as part of a building management or industrial control systems. And if you look at the graphic there, we're kind of showing this, and the example is an industrial process example where I have 4 machines represented by in blue there, but we have some machines which we've deemed non-critical, some machines which we've deemed critical. So in the case of the critical machines, we're providing the UPS to back up the main power of the system. But we're also showing as a separate control power connection. Again, this is the power, if you think of it, it's not providing any muscle to the system, no motors, no drives, no magnetics or anything like that. This is just the brains of the system and the devices that the system is controlling. In this case, the example we're showing is a centralized UPS to provide those systems. So if the main power goes down for some reason, whether it's deliberately taken down for maintenance reasons, whether you have a utility power loss, or whether somebody pulls a safety cord, for example, in an industrial environment, there's a variety of reasons that power may want to come down, but you may want to have lower power available in the systems to continue to collect data. Also provide safe power from a maintenance perspective at potentially a lower available voltage and so forth. And then separate from that is the network to these systems. This network can include the controllers, the devices, that whole IoT connected world. You want that network backed up. Now, within those machines, you may also have local networks that are backed up from the control power UPS, but that upstream network needs to be available, needs to be maintained if you truly want to leverage this IoT space. I wanted to show just an alternative example of how you could do this, and it's both ways and variations in between. And you could apply this again to a building management system, but using an industrial process example. Again, what I show here is a couple of UPSs on critical machines, central UPS for control power. An alternative approach as an example would be a single UPS or a centralized UPS for backing up a number of critical machines, and control power derived locally at the machines with a local UPS in the machines. Now, in the case of the critical machines, this actually is showing a sort of a redundant or layered approach. You may not need the local one, but again, there's all kinds of events besides the main power loss that could potentially trigger a power loss. So again, if you look at this, this is, outside of the critical machine main power UPS is a cost-effective way to maintain the highest availability in an IoT connected environment. Talked about generators. Gensets play a role in many people's facilities, depends on the type of facilities. I use hospitals as an example because they always have gensets. But if you look at hospitals, they'll define to some degree by code what their essential loads are. These are the loads that are a subset of all the power loads that are protected by gensets. Less defined by code, or arguably not defined at all, would be what additional loads require protection for the period of time it takes generators to come on. That might be 8 to 20 seconds depending on systems. By code in hospitals, it's actually 10, or 10 or less, I should say. But the hospitals typically will define a subset of those essential loads that also require UPS backup for bridge power, so to speak. That is, that time it takes for the generators to come on. Now, in a lot of environments where generators aren't present, it's just going to be, at least what the graphic would show would be your non-essential and your critical power distribution. And we're less concerned with bridge power than we are complete power from the UPSs, which either provides for extended outages or at least enough time to shut the systems down in a manageable way. It's also becoming harder depending on where you're at. If you're on the West Coast, for example, it's not an easy thing to get approval to use a fossil fuel based genset. So in some cases, it's a mix between those essential and critical systems as we define them here. I'll leave you with 3 questions in this space to consider. Again, what equipment? It's part of a risk analysis. From asking the question, what happens if we lose power? You'd be amazed how often it's not asked. Ask your people, what is the effect of a power loss? What is the effect of a blip of power? What if we lose power for 2 seconds? Chances are you'll find out it's a lot bigger than a 2-second impact. But it can be from something as simple as that to conducting a more formal risk assessment to understand, how dangerous is unplanned downtime, how expensive, what happens if we don't see generators, what type of events need to be recurred, and what does it take to recover from these events, okay? And also think about any loss of priceless or critical data. Critical data can be transaction data. It can also be event-type data that is critical because of the analytics that you're trying to put in place relative to this IoT connected world. And again, if you can't tell, I'm excited to talk about this subject. I think it's not a revolution, it's an evolution, but it's an evolution with impacts that companies that get on board, use it correctly, put the right protections in place are going to be some of the most competitive, most compelling companies in our space, and excited to be a part of it. I'll be happy to take any questions that we can accommodate in the time we have left. So thank you so much.
Thanks, Dan. Thank you very much for that presentation, and we do have time for several questions, so I will launch right into that. You had a slide toward the end talking about with an example of the deployment strategies and explaining some of that. So we had some questions about what is typical in terms of deployment strategy, and as a kind of related to that, maybe you could talk a little bit about how the backup power elements or UPS elements for the brains, as you've been talking about, are different or similar to the elements that may be used for the more traditional mains in facilities.
Yes, thanks for the question. And the question includes a phrase which is a great one, which is a deployment strategy. Part of looking at your process, and this can be when it can be your manufacturing process, your facility process, or your facility architectures, is it's looking at it when you're designing those systems, but also if you have those systems in place, looking at them from a continuous improvement perspective in terms of what are the pain points. That's part of that risk analysis and asking that question, but coming up with a deployment strategy. Now, if we want to talk about what's typical, and I'll use these graphics as an example, in a lot of spaces in a non-IoT connected world. So when you think before the IoT, truth is a lot of this isn't in place. If there's a power outage for virtually any reason, these systems go down, the networks stop talking to each other, faults fly everywhere that tell you this device isn't communicating with this device, that device isn't communicating with this other device, and you get this cascade of information which is not useful to you running your process efficiently and improving your process. And you also have issues associated with bringing those systems back up, okay? It's the more forward-looking companies that are putting systems in place where they recognize they have critical chains in their process. That's where you see the mains type applications, and then where the data is potentially valuable to them and they want to keep the control systems alive. So more and more what we're seeing is people using this type of approach where they're spot applying UPSs at the control level, okay? And then where they identify, so not all of the UPSs like you see here, but used occasionally in places, and then where they have critical spots identified, putting a UPS in place more like this to protect, say, a critical machine. Also, when we get into process control environments, we're more likely to see the central control power UPS. If you look at the example, what we show here is two separate power feeds coming to the machine, one for the main power and one for the control power. Typical main power UPS is going to be, it depends on the size of the system, but we might be talking about a three-phase UPS that's fed from 480 volt, feeding 480 volt to a system that goes into the main circuit breaker or fuse set for the machine. So it's actually the power source for the machine. And the types of UPSs that Schneider and others provide typically would be what we call a double conversion UPS, which means you're actually relying on the UPS to generate power. The battery backup is actually backing up the UPS. It's not backing up the machine, so to speak, and it's just constantly, you're not touching the utility power. The utility charges the batteries and the DC bus. The DC bus and the battery provides the energy that the UPS needs. For the lower power control UPS, that's typically more of a single phase system. So you're talking 120 volt single phase system. It might be, if you have a highly enough centralized system, a three-phase system that goes to a control power distribution scheme that breaks it down into typically 120 volt that's feeding off each of the three legs, so to speak. And then also when you get into the panels, they're going to break that down to a lower voltage DC, typically 24 volt in industrial and commercial building environments. In that edge IT integrated environment, we're talking about a rack solution, okay, much like Schneider Electric and others provide, which is IT racks that support servers, network switches, and other hardware, and you're going to have UPS systems integrated into that are also rack-based. That's sort of the landscape of those systems. Then you get also into the form factor. Are they in a highly industrialized environment, which means sort of a NEMA type environmentally controlled enclosure, or is it in an IT closet or a closet on the manufacturing floor, in which case it's more of a commercial grade type system.
Thanks, Dan.
Any other questions? Thank you.
Actually, well, we're running up against the clock, but I do just have a quick question about in your cybersecurity section of your presentation, you talked about unmanaged systems and that being part of the concern. So can you just briefly describe again what these unmanaged systems might be, or what that means, and how do you address those, depending on what they are, I suppose?
Yeah, and it's very possible that some of the fine folks on this call may have firms that are well ahead of this curve. But in a lot of facilities, industries, and so forth, you walk into the facilities and you go beyond the data center or the IT room in the facility, and you're going to find systems, computers, and so forth that are connected to the network somehow, that are entirely managed outside of the IT network. They were either procured by the department, may have been procured by a value chain member, like a process equipment provider or a mechanical equipment provider. I know I used to work in the factory automation space, and I had, I'll share a question with you at the time I thought was a stupid question. It's since evolved into a relevant question, but I was asked by somebody if we could run McAfee antivirus on our programmable logic controllers. And at the time I said there's never going to be a virus created for programmable logic controllers. If any of you know some of the Stuxnet stories and things like that, that's proven not to be true. But what my point was to him is probably his biggest security loophole is myself and other suppliers that walk into their facilities with laptop computers and connect to either their industrial control systems or their building management systems. So I have a completely unsecured piece of hardware that's connecting to those networks. But the reference here is also to those facilities that I speak of. You walk into them and you're going to find somebody who has, for example, a WinXP box that's never had a security update or a operating system patch, working in an environment that from an IT perspective is supposed to be Windows 7 and completely managed. Those systems get put in, they don't get managed, they never get touched, and it is outside that environment, and it's an attack vector point because it's outdated and it's unsecured.
All right, thank you, Dan.
Good question.
And it looks like we are out of time, so I want to thank you for your presentation and to Schneider Electric for sponsoring the webinar. Thanks again, Dan.
Thank you so much.
And also, and thanks, of course, to all our attendees for attending and for sharing some of your questions. To let you know, a recording of the webinar will be available online at facilityexecutive.com, as well as on the Schneider Electric website at schneider-electric.com. So thank you very much. And please don't forget to register for our upcoming webinar, which is titled Making Buildings Bright and Smart Using Lighting Control Systems. That's on September 22nd at 2 p.m. Eastern Time. And to register for that webinar or to view archived recordings of past webinars, you can visit facilityexecutive.com/webinars. Thanks very much and have a great afternoon, everyone.